Hey guys, how's it going? So in today's video we'll be talking about DeMoivre's theorem and trigonometric identities. So let's get straight into it. The first part we need to know before attempting any sort of questions is we don't understand what the DeMoivre's theorem is. So right here I've gotten the standard form of the DeMoivre's theorem, like it says z to the power of n equals to r to the power of n brackets cos n theta plus I sine n theta. So there's a massive, so we can get a whole proof of this in textbooks, but that just takes too long to explain, so we'll just stick with that for now. And for the negative case, we've got z to the power of negative n, which equals to r to the power of negative n, cos n negative theta, we're going to be careful, the theta becomes negative, plus I sine n to the negative theta. So let's go straight to the example. So the first example says, given z equals to negative 3 plus I, negative root 3 plus I, z equals to that, find z to the power of 7. So the first part, or the first thing I will do is I'll change that into this form right here. So the mod arg form. To do that, we get z equals to, we can take the modulus of that, which is, so modulus of z, sorry, we'll take the modulus of z, which is square root of root 3 all squared plus 1 squared, because that's just I, which then equals to square root of 4, which is 2. So the modulus here is giving us 2. So we can write that down over here. We'll just go 2 brackets, draw that on the argand diagram, which then helps us get the argument. So we've got, let's do it over here. With the argand diagram, we've got real, we've got imaginary. So minus root 3. So minus root 3 is the real component. So that's somewhere around here somewhere. Minus root 3. And then plus I go up over here. So that is the complex number we have at the moment. That's the complex number. So we're trying to find this theta here. So easiest way first I would suggest is we find this angle right here, which is we could just go to arctan, so tan inverse of theta. So that's just, this value here is just 1. So 1 upon, so minus 1 upon root 3. So we get that. That's the value of the inside angle. So the answer to that would be inverse tan of 1 upon minus root 3. So we get minus pi on 6, 30 degrees. So the answer is minus pi on 6. But we know that that is this angle here. We're trying to find this. So we just go 180 minus that. So 180 minus 30 is 150. 180 is 5 pi on 6. So the theta for us is 5 pi on 6. So we've gotten 2 cos 5 pi upon 6 plus I sine 5 pi upon 6. So I'll rub all this out so that don't get confused. This right here can go all go. So we've got that. And now we just do that. So that is z. So if we go to the power of 7 equals to all of this to the power of 7. So this then becomes, from DeMoivre's theorem over here, we just sub in that. So we get 2 to the power of 7, brackets, cos 7 times 5, which is 35 pi upon 6, plus I sine 35 pi upon 6. So that's our answer. 2 to the power of 7 gives me 128, I believe. 2 to the power of 7 is 128, that's right. So 2 to the power of 7 gives me 128 brackets, because I've just times 5 times 35. So this is out of the principal argument. The principal argument of a complex number is negative pi less than arg of z, which is less than or equal to pi. So since it's out of the principal argument, we need a minus 2 pi every single time until it gets in the principal argument. So if we minus 35 upon 6, so you can put that on your calculator, 35 divided by 6 minus 2. So we get 23 upon 6, that's still not in the principal argument. So we keep minusing 2 from that. We get 11 upon 6. And then we get negative 1 upon 6. So we minus 2 until we get that in the principal argument. So we get negative 1 upon 6. So the final answer then becomes 128 cos to the power of negative pi upon 6. Sorry, not to the power, cos negative pi upon 6 plus I sine negative pi upon 6. So yeah, from here we go, so 128 cos negative pi upon 6, so that gives me negative 5 upon 6 cos negative 30 root 3 on 2, so we get 128 brackets root 3 upon 2 minus sine 30, sorry, my bad, yeah, minus 1 upon 2 I. So if we just cancel out the 2's with 128, we get 64 brackets root 3 minus I. So that's your final answer to that question right there.